Okay, so the final part here is an introduction to the sine, cos, and tan graphs. This is the same sine, cos, and tan from before. Okay, and these can actually be graphed. And what you have is you have degrees on the x-axis, and then here on the y-axis you have the values that they can return. So you would have seen so far that when you did sine of some angle or cos of some angle, you got an answer between 1 and -1. And this is the range. Okay, so we call this the range. This is what the answers range between, what the y ranges between. And what we are looking at in terms of x, and what is given to us in terms of x, this we're going to call the domain. And these terms will be very important later in the A level. Okay, and you'll notice that sine and cos have, very similar shapes here, but they don't give you the same values in most of the points. They tend to cross at different points, have their maximum of 1 at different points, and their minimum of -1 at different points as well. Whereas tan, tan looks very, very different indeed. So a sine graph starts at 0, goes up to 1, and then curves down. It should have this smooth shape, okay? It's not a dot to dot, it's the smooth shape. Notice as well that after 360 degrees, it begins to repeat itself and continue the same journey also. That's very important for sine and also for cos, that idea. So sine of 30, you might remember, this is one of your exact values, and this is a half from GCSE. So a half is sort of here, okay? And, you could extend this over here as well. So thinking about symmetry in the graph, because there are interesting symmetrical points on sine and for cos, what would sine of 130 be? Do you remember from earlier with the ambiguous sign? We said that when we're looking at sine, so let's say when we're looking at sine, that if we have an angle here, that's the same as 180 minus that will give you the same answer. So sine of 150 must also be a half if sine of 30 is a half. What about sine of -30? Because you can go to negatives as well. Well, again, there's kind of a bit of symmetry going on here, but clearly it's not going to be a positive answer. When I say symmetry, yes, this is sort of rotational symmetry instead of reflecting. And this will actually give you -1/2. So it means there's a shortcut that if you want to know what sine is of minus, so say -30, you can actually just say, well, it's the same as what sine of 30 is, and then make that a minus. This is because sine is an odd function. If you have this situation, that this is called an odd function. So if you wanted to find sine of -45, for example, you could just do sine of 45 and make it negative. Okay, finally, sine of 210. So 210, this is sort of 30 onwards. Yeah, it's 30 onwards from 180. So 30 less than 180, that was the 150. 30 onwards is 210. And it probably won't come as a surprise to you that that will give you -1/2. How about cos then? Cos, very similar. Cos, I always remember as starting as 1 and instantly falling, okay? And every 90 degrees, you complete a step from 1 to 0, 0 to -1, -1 to 0, 0 to 1. The key steps for sine and cos, okay, the key steps, which will be, some kind of 1 to 0 to -1 to 0 to 1. This is always every 90 degrees. So I think of it this way and then connect it in this flowing way. Cos also has symmetry about its y-axis as well, okay? So let's do the same thing again. cos 60 is a half, and we might know that from exact values. So cos 60, where's that? That's about, well, we could draw a line on. It's about a half. Okay. You might spot straight away, because it's symmetrical, if you go 60 there, it's sort of the same as going 60 there. So cos of minus 60 will be a half. That might be the most obvious one to pick out first. What about sine of, sorry, not sine, cos of 120? Well, when we had 60, it was like going 30 back from this one. If we're doing 120, it's like adding 30 on to this one. This one will be minus a half. Cos of 240, so more complicated, again, I would say. We're sort of in this situation over here. But can you see some of the symmetry going on? Okay, that's why we would get the same answer for cos 120 and cos 240. You don't need to know this yet, but you will see in chapter 10, as there was a rule for sine, there's a rule for cos. And the rule for cos is this. If you want to use that symmetry there, both of the angles, what's that, about over 100, 200 something, both of the angles will add up to 360. And this is how we write it, okay? So if you wanted to know what cos of 300 was, this would be the same as 360 minus 300. In other words, it would be the same as cos 60. Cos 60, we know, would be a half. So we can also add to that cos of 300, for example, would be a half. And you can see that from the diagram. Yeah, this is about the 300 point. Okay, finally, the tan graph then. So the tan graph is very, very different. And chapter 10 is best for understanding where the shape of tan comes from, but it's really very different to sine and cos. It's not limited of just bouncing between 1 and minus 1. You'll also notice that it repeats, but it doesn't repeat every 360. It repeats every 180 degrees. Okay, going through 0, 180, 360, and so on. And it has these lines here. So these lines, these asymptotes, if you try typing in tan 90, for example, on your calculator, it will say no. Okay, it will say mathematical error, because it's not possible to do tan of these asymptotes. But I will leave tan mostly for chapter 10, as I believe it makes more sense where it comes from. For now, we just need to be aware of the graph and how it looks. Again, there is sort of some symmetries and some sort of reasoning that you can do by using the shape of these graphs. So tan 30, might be about here somewhere, is 1 over root 3. Well, what about if instead of to the right, you go to the left? We talked about something just like this with the sine and cos graphs. So this is what we would get. This works because tan is also an odd function, okay? That means if you want to do sort of like a negative, so tan of a negative there, you could just do tan of whatever it is, and then just make it a negative at the end, okay? Tan of 150, so what I like to do if there's a large number, well, because it repeats every 180, instead of looking at 150, you can take 180 off it, which will give you minus 30, and we just work that one out. You get the same answer. You'll get minus 1 over root 3. Okay, so we have some rules for sine and for cos. We need to know how often they repeat. And here you should pause the video and have a quick go at these questions here. So what are some simpler ways that you could state the same value here by adding and taking away 360 or 180 if it's tan, by using these rules here, so that everything is in terms of a 30, a 45, or a 60. Pause the video, have a go. So I'm assuming that you've had a go at that now. You should be able to express them in 30, 45, and 60, and you will know if you have done that or not. And then as a final step, if you enter the values, this is what you should get for these here. Final part, which we'll just very quickly discuss, is transforming them. So as you would have seen in chapter 4, you need to start with the regular graphs and think about if the change is inside or outside the function and how this will affect things. This is a stretch, scale factor 4 in the y direction. So instead of being between 1 and -1, it's 4 and -4. Here, this is a translation inside the function, so we do the opposite. So we need to move the cos graph to the left by 45, and it will look something like this. Word of advice as well, you may wish to use a calculator with a table of values just to sort of help you sketch some of the points with a little bit more certainty. Okay, pause the video, have a go at these two transformations on the screen. And if we've done that, we have a reflection. Okay, so instead of going this way, this is being reflected in the x-axis. This is a transformation inside the function, dividing by 2. So this will actually stretch in the x direction by a factor of 2. It only wants between 0 and 360. So you won't actually draw a full cycle of sine here because it would go like this for the rest. So you get just this sort of hill shape. Okay, and that leaves you with the exercises at the end of chapter 9. Sine, cos, and tan are revisited quite extensively in chapter 10.